Okay, welcome back everybody. In this video we're going to look at two more derivative shortcut rules, rules 5 and 6 of our initial rules, the product rule and the quotient rule. These two are a little bit more advanced and a little bit more difficult than the ones we've talked about so far. So let's kick it right off with rule number 5, the product rule. The product of two differentiable functions u and v is differentiable, and the derivative with respect to x of the quantity u times v is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. In shorthand, the derivative of u times v is u dv plus v du. And so we take each individual function times the derivative of the other when we apply the product rule. And you see the proof is written out here for the product rule. It's a pretty cool proof. I recommend that you stop and take a read through this and make sure you understand it before you really move on. But I'm not going to read through it in this video. You can read it at your own leisure and see if you understand everything. If you don't, let me know, and I'll answer your questions on it. But I'm going to move directly into examples on the product rule. Now, since the only thing we know how to take the derivatives of so far is polynomials, the product rule is not as interesting and useful as it's going to be for us later when we know how to take the derivatives of many types of functions other than polynomials. So we're just kind of doing these to make sure we get practice. There are other ways to attack both of these, which you saw when we went through some of the examples with rule number 4 yesterday. We could expand this out and then use the sum and difference rule. But instead, today I'm going to use the product rule. And so the derivative here, dy dx, is equal to, and these are our u and v. And so I've got u times the derivative of v, the derivative of 3x to the third minus 5 is just going to be 9x squared. So there's my u dv plus v times the derivative of u. And the derivative of x squared plus 2x is just going to be 2x plus 2. And now I'm going to go ahead and simplify this. And so let's see, I've got 9x to the fourth plus 18x to the third. And then when I expand the second set out, I've got 6x to the fourth plus 6x to the third minus 10x minus 10. And now I want to combine my like terms to arrive at my final derivative, which is going to be 15x to the fourth plus 24x to the third minus 10x minus 10. And that's the derivative of the product of those two original functions. Alright, now, in this second one, I've got y equals the quantity 2x squared minus 5x plus 6 raised to the second power. I'm going to think about this as 2x squared minus 5x plus 6 times 2x squared minus 5x plus 6, and apply the product rule to it. And so the derivative of this is going to be u times the derivative of v, and the derivative of v here is just going to be 4x minus 5 plus v times the derivative of u and so I have two identical things here. Both of these expressions are identical with one another, and so I can simplify my simplification process a little bit by thinking about this as 2 times 2x squared minus 5x plus 6 times 4x minus 5. And so I'll go ahead and simplify what's inside the brackets here. And we've got 8x to the third minus 10x squared minus 20x squared plus 25x plus 24x minus 30. And now I'm going to combine my like terms inside the brackets. Gives me 8x to the third minus 30x squared plus 49x minus 30. And then I'm going to distribute the 2 through those brackets. And we have that our final derivative is 16x to the third minus 60x squared plus 98x minus 60. Alright, and that is the product rule. Alright, continuing on, let's look at the quotient rule. The quotient rule is for when we have a fraction y equals u over v. And here's our rule right here. The derivative of u over v is equal to v times du dx minus u times dv dx all over v squared. There are a lot of mnemonic devices to help us remember this. There's a little quotient rule poem that I've heard. I don't know quite who to attribute it to, but when we use the quotient rule, we sometimes use the little poem to help us remember what order to do things, but it is, where u is high and v is low, we have our derivative low d high minus high d low, square the bottom, and away you go. That's a little way for us to remember what exactly is happening in the quotient rule. I didn't put the proof in here. If you're interested in looking at the proof, you can look up quotient rule proof online, and I'm sure you can find many examples of the proof of the quotient rule. You can also look up quotient rule poems to find other ways that people remember the quotient rule. Me, I never really felt like I needed a mnemonic device for this. I always just thought of it as v du minus u dv all over v squared. And that worked for me when I was a calculus student. So here we go. Let's apply the quotient rule. Y equals x squared plus 4 over x minus 1. And so dy dx is equal to low times the derivative of high minus high times the derivative of low. I'm going to square the bottom, and away I go. Now all I need to do is simplify what I see in the numerator. And so I'll multiply these things out. It gives me 2x squared minus 2x minus the quantity x squared plus 4 all over x minus 1 quantity squared. And simplifying this, I get x squared minus 2x minus 4 all over x minus 1 quantity squared. Now sometimes when we're doing quotient rule problems, we'll have opportunities to simplify, factor things out of the numerator that will then cancel with the denominator and things like that. In this case, that's not really going to happen for us, so we're going to stop right there. Alright, second example. We've got dy dx equals low times the derivative of high minus high times the derivative of low, square the bottom, and away I go. Alright, now I need to simplify my numerator here. And this is going to get a little bit ugly for us, a lot of terms, a lot of opportunity for us to make mistakes. So you've got to be really careful in this simplification. So I'll multiply the x squared through, multiply the 2x through, multiply the 1 through, And then I do the same thing with the second quantity, and I'm going to subtract that whole quantity away. And I'm going to have 2x to the third minus 2x squared plus 4x squared minus 4x and plus 2x minus 2. Don't forget about your denominator. I've seen a lot of students over the years drop their denominator in problems like this one. Alright, and now I need to clean this stuff up. I'm going to cancel a few things out. I've got a 2x cubed in here. I've got a minus 2x cubed. I've got a minus 4x minus a minus 4x. I've got a 2x minus a 2x. And now I can combine my like terms here in the numerator. I've got negative 2x squared minus positive 2x squared. That gives me negative 4x squared. And I've got 2 minus a negative 2. That gives me a plus 4. All over x squared minus 2x plus 1 quantity squared. Now I look at this and I think I want to try and simplify this a little bit more. I can factor a negative 4 out of the numerator, and that turns this into negative 4 times the quantity x squared minus 1. I also recognize that x squared minus 2x plus 1 is the quantity x minus 1 quantity squared, which we're squaring that. And further, I recognize that I can factor x squared minus 1 in the numerator as x plus 1 times x minus 1. And down in the denominator I have x minus 1 to the 4th. And now I can cancel an x minus 1 from both numerator and denominator, and I end up with my derivative being negative 4 times the quantity x plus 1 all over the quantity x minus 1 to the 3rd power. And there's my derivative. Alright, you see how this gets a lot more involved than when we were just doing problems with the power rule and sum and difference and constant multiples. The product rule and the quotient rule especially get considerably more involved in the simplification process. Anyway, that's it for this video. I'm going to come back in the next video and look at rule number 7 and a few examples of some general approaches using these rules. And we'll see you next time when you're watching that video. Hope you have a great day and see you in the future.